Okay, so today we're going to figure out simplifying radicals with numbers and variables. And to start out, we want to think about what raising something to the second power does when we're square rooting that number. And if you remember last time, we said something to the second power and a square root will cancel because they're opposite operations. So in this example, we would say, 6 to the second. The square root of 6 to the second means our answer would just be 6, because the square root and the square will cancel. Well, if we have a variable, the same thing will happen. So that square will cancel with the square root, and we'll just get a. And if you remember from the last video too, we can separate square roots, since there's only multiplication in between. And we can go, that's squared, and that radical will cancel. That's squared, and that radical will cancel. And I'll get a, b. So again, the big important thing today is to realize that a squared will cancel a square root. Let's try a couple more problems. Okay, let's try variables to higher powers. If you remember from before, we can kind of split up square roots. So I can think of this as a to the fourth, which was really a times a times a times a. Now that's not really helpful. So I'm going to go back and combine these things. I'm going to combine them a little bit differently. And I'm going to go, well, this is really a squared times a squared. And then I can use the trick that we did before and go, we can separate this. So I can look at this as like the a squared and a squared, and we can go, what do square roots do? Well, they cancel things that are squared. And so we can get this answer is a times a, which is really a squared. Okay, let's look at what that kind of did. So we can see like this whole math pattern, but I might not want to do that every single time. What did this square root do to the fourth power? Well, when we split it up, it canceled the two a squareds, and then we recombined them and got a squared to the end. So if you watch what the 4 happened to the 2, maybe we can figure out a faster pattern. Let's look at a to the 7th, or a to the 8th. When I do a to the 8th, it's a similar process where I would have 8 a's. Well, I'm not going to write 8 a's. I'm just going to write the 8 squares that kind of make this up. So I got 8 squared times 8 squared times 8 squared times 8 squared. And if you go through and add those up, because when you multiply exponents, it acts like adding, so you'd have a to the 8th. Well, then I can go through and I can separate this. And then I can start canceling the squares and the square roots. And what I would get is a times a times a times a, which that's 4a, so that's just a to the 4th. So again, watch what that square, or that's like having a square root does to an exponent. Let's try this one. Again, this is going to be very similar. You'd have a squared times a squared times a squared times a. And again, I would want to separate the terms. And then I would go, well, this will cancel, this will cancel, this will cancel, this can't cancel. So because it can't cancel, I'll just leave it. And so I'll have a times a times a. Well, that's 3 a's. And if you're looking carefully, what it looks like square roots are doing to exponents is it looks like it's dividing them by 2. Because a to the 4th became a to the 2nd, a to the 8th became a to the 4th, and a to the 7th came a to the 3 remainder 1, which 7 divided by 2 is 3 remainder 1. So there is kind of this faster way. We're going to use this method today, though, and think about how many like a squareds make up this exponent. Let's do a couple more examples. Now we're going to have multiple variables. And again, the first thing we kind of want to do is break it up to its 2 different spots. Then after that, we can start simplifying. This will just become a. This would become b squared times b squared times b squared times b squared. That will cancel. So all these will cancel that square root. So I'm going to have a, and then that would be 4 b's, so that would be b to the 4th. In this case, again, we will separate the two things. In this case, I'll get a squared and a squared. In this case, I will get b squared, and b. These two will cancel with the square root, and I'll get a, well there's 2 of them, so I'll get a squared. These two will cancel with the square root, but this one will be trapped. So I'll get b squared because I have 2 b's, and I have 1 under the square root. Last one here, and we're going to see if we can do this one without writing everything out because there's so many terms. Whoops. When I look at this, I go, okay, how many a squareds would make up 9? Well, there would be 4 sets of a squared and 1 a left over. So really, what this would look like is a to the 8th and a. Because 8 and 1 would get me to 9, and we've already done a to the 8th a lot of times. That's really a to the 4th. There's 4 sets of a squareds in there, and I had 1 a left over. This, b to the 6th right here, would just be a to the 3rd, because 3 a's make that up, or b to the 3rd, because there's 3 b squareds that make that up. C to the 7th would really be c to the 6th and c to the 1st, which that would be c, like 3 c's that make that up, and that's under the square root. Let's combine this to make it a little bit nicer. So things that are not in the square root would be a4, b3, and c3. And the things under the square root would be ac. Hopefully you're getting a better idea of how to simplify some of these variables. Again, it's about thinking about this pattern of 2's and then thinking these 2's will cancel. Let's do our last kind of examples. Now we're going to combine what we did yesterday and today. And I'm going to go, oh, these things have numbers, but we can deal with the numbers pretty easily, just like we did yesterday. We have to think about the perfect square root that makes up 8. And the perfect square root that makes up 8 is 4 and 2. And this one is broken up by a to the 6th and a to the 1st. Well, the square root of 4 is 2, and the square root of 2 is just the square root of 2. The square root of a to the 6th is a to the 3rd, and the square root of a is just a. Now I can recombine. And that would be my final answer. Let's do 90. If I'm looking at 90, the perfect square root that makes up 90, so I got to think about all the ones that I remember from before, would be 9 and 10. Then we're going to break up these a's. So that would be a to the second and a. And the nice part is I know the b's are going to cancel. So that would just give me b. Now we would just take some square roots. The square root of 9 is 3. The square root of 10 is just 10. The square root of a to the second is a. The square root of a just stays as a. Now we would just combine these numbers out in front and put the stuff under the square root back together. So my answer would be 3ab square root 10a. Now let's try this last part. Again, I would take 12. What breaks up 12 is 3 radical 4. Those are the perfect square roots. Then I'm going to think about a to the fourth. Well, a to the fourth we know will become a squared. And then b to the sixth is going to become b to the third. And c to the seventh is going to be radical c6 and radical c. Well, the square root of 4 is 2, and the square root of c to the 6 is 3. And now we have to combine that with all our other things. So again, I'm going to combine the stuff that are outside the radicals. These numbers can multiply, so I can get 10, a to the second, b to the third, and c to the third. And then I can combine my square roots, and my square roots would give me 3c. And that would be my final answer. Again, today, how you deal with the variables is you try to make these squareds, because you know that a squared will cancel with the square root. And then you deal with the numbers the exact same way that we did yesterday. We try to think of the perfect square root that will go into this number. So it's still important today that you remember that list that we made yesterday. It was like the square root of 1, the square root of 4, the square root of 9. Like, you still need to remember all of those kind of things so that you can take this number and simplify it. Try the examples today.